To find the range of values of x that satisfy the inequality x minus 3 into x minus 4 less than x minus 3. This left-hand side here is made up of two linear factors, so we have to open the bracket first. So x multiplied to x is x squared, x multiplied to negative 4, negative 4x, negative 3 multiplied to x, negative 3x, negative 3 multiplied to negative 4, we have plus 12 less than x minus 3. This gives us x squared minus 7x plus 12 less than x minus 3. Let's bring everything to the left hand side. And so we have x squared minus 7x, taking this plus x this way, minus x plus 12, taking this negative 3 this way, it becomes positive 3 less than 0. And so we have x squared minus negative 7x minus x, negative 8x, 12 plus 3, 15, less than 0. We have here a quadratic inequality. We now proceed by factorizing the left-hand side. The leading coefficient is 1, so all we need to do is to get two factors of 15, whose sum is negative 8. Which are those two factors of 15 whose sum is negative 8? If we list the factors of 15, we're going to have plus minus 1, plus minus 3, plus minus 5, plus minus 15. So that we choose from this list two values such that their sum is negative 8 and their product is 15. Clearly, we see that we choose negative 3 and negative 5. Negative 3 plus 5, negative 3 plus negative 5 gives us negative 8. Negative 3 multiplied to negative 5 gives us positive 15. So we now have x minus 3, x minus 5 less than 0. If we open out this, we're going to get this left-hand side. We have the product of two things less than 0. So how do we proceed from here? We get our critical points. Critical points. If we set x minus 3 equals 0, our first critical point will be 3. If we set x minus 5 equals 0, our next critical point will be 5. And so we go on the number line. We indicate the critical points. We have 1, 2, 3 regions to test. We should also remember that less than 0 is another way of saying negative. Values less than 0 are negative. If you look at the number line, 0 is always in the middle. Values to the right of 0 are positive. Values to the left of 0 are negative. Values to the left of 0 are negative. And so here we will say this zone here is less than 0. This zone here is greater than 0. So less than 0 refers to negative. Okay. We now test values from this zone, and see the ones whose product, this product here will give us negative. It will mean our solution lies in those zones. So let's start with if we take this zone, a value here, a value in this zone here, any value less than 3, for example, 2, We take a value in this zone here. A value less than 3 can be 2, it can be 1, it can be 0, it can be any of the negative values. All right, let's take for example 2, and we put in this expression. 2 minus 3 is negative 2. We're interested in the sign, so we just write negative. We have negative. We're interested in the sign, so we have negative. And then 2 minus 5 is negative 3. So we also have negative. The product is going to be positive. Okay, so here we have positive. And pay attention, we are looking for negative results, so we don't expect a result to be in this zone. Let's take a value in this other zone. We take a value here, for example, 4. 4 lies in this zone, and we do the same analysis. We put 4 here. 4 minus 3 is going to be positive. 4 minus 5 is negative. Positive multiplied to negative gives us negative. We take a value in this other zone, for example, 6. We put it here. 6 minus 3 is positive. 6 minus 5 is positive. Now, positive multiplied to positive gives us positive. But we are interested in the zone where our values are less than 0, and less than 0 is negative. Therefore, our solution exists between 3 and 5. So we say our solution set will be all real values of x such that 3 less than x less than 5. This gives us our solution set for that problem.